This is Algebra 2. We're going to do a little more practice with Newton's law of cooling. The reason I chose this assignment is because of the way the formula is set up on this. This can be used as exponential growth and decay using the formula T of t equals AEKT plus TG. The reason I picked that is because on the Regents reference sheet, if you look at the bottom down here where the formulas are, this is the Regents reference sheet, the formula with growth and decay has the E formula in it. It's basically the same formula. AEKT minus T0 plus B0. It's the same formula. So if you're stuck for an exponential growth and decay formula, you can use this formula. It's a little harder, but it works out quite well. Okay, so let's take a look at the example here. We're going to do this example together, and the other one you can do on your own. Okay. A pastry taken from the oven with an internal temperature of 165 degrees is placed in a 35-degree refrigerator. After 10 minutes, the pastry is cooled to 150 degrees. If the pastry cannot be eaten until it has cooled to 70 degrees, how long will you have to wait to the nearest minute? Okay, so using Newton's law of cooling, using the E formula instead of the A, B to T, what we can do is figure out our values. So let's look at what we have here. Okay, so first of all, the temperature of the surroundings we know. The temperature of the surrounding would be the 35. Okay, that would be 35. This would be T of G. Okay, so this would be 35. Okay, now the other parts is what we have to figure out. We have to know what A is, and we have to know what EKT is in order to figure out what the temperature is going to be. All right, we need to figure out what the T, little t is for the temperature, or the time, I'm sorry. So we have to know what K is, and we have to know what A is. All right, so the first thing that we're going to do is find what A is. All right, so let's find what A is. All right, so the formula says T of t equals AEKT plus TG. All right, so we know this is going to be plus 35 is the end. All right, and we have to find A, E, K of T. All right, now we need to plug in a time so that we can find A that would give us a value. All right, so, well, why don't we just use 0? All right, because we know what the starting temperature is. All right, so if we know that T is 0, it would be K times 0. And we know the temperature at the start, the temperature is 165. So that would go over here. Okay, so now that we have the formula, let's work this out. This gives me 165 equals A, E, K times 0 is e to the 0 plus 35. All right, what's e to the 0? Well, e to the 0 is equal to 1. If you're not sure, anything raised to 0 power is always 1. All right, just to show you, second e raised to the 0 is 1. Anything raised to 0 power is 1. Okay, so this is 165 equals A plus 35. So if we subtract the 35, that gives me A equals 130. Okay, so now we've got some more of the formula. We have T of t equals 130 E to the KT plus 35. All right, this is the TG, this is the A that we just found based on this formula. Okay, now, in order to find T, we need to know what K is. K is a little more complicated. All right, in order to find K, we need to fill in the other values. So what we need to know is another value of time. What other value of time do we have? Well, we have 10 minutes. So if we use T this would be the temperature, T for that. So if we plug that in, won't that give us K? Yeah, it will. All right, so T is 150 at that temperature. And I plug in the rest of this, e to the k times 10 plus 35. All right, so 150 equals 130 e to the 10k plus 35. Okay, so I need to solve this for k. So this works out to be a natural log problem because I need to find an exponent on an e. So let's just solve it like we normally do. Subtract the 35. And that gives me 115 equals 130 e to the 10k. I want to divide by 130. right, and that gives me 115 divided by 130 is, math, enter, 23 over 26. Okay, so that gives me, let me put down here, 23 over 26 equals e to the 10k. Okay, so this is going to be an e problem, so we have to take the natural log of each side if we're using e. So it's ln of 23 over 26 is equal to, remember this is an exponent, ln of e to the 10k. This is an exponent, so this comes out to be ln of 23 over 26 equals 10k ln of e. All right, now remember ln of e is equal to 1 because it's e to what power is e? It's going to be 1, so that works out to be just 1. So then to solve for k, we have to divide by 10. All right, so that means that k is going to equal ln of 23 over 26 divided by 10. That's what k is equal to. So if I put that in my calculator, it's going to be kind of messy. ln of 23 over 26, and then make sure you close your parentheses, divided by 10. Okay, and I get this decimal. Okay, so it's negative 0.012260232. Let me write that down. Okay, so k is going to equal negative point, what was the rest of it here? 0.01226. I don't think that makes a fraction either. 0.02322. 0.02322. 0.02322. All right, now notice I didn't round that off because I want the exact value. You can round it off if you're told to, so that's fine. All right, so now we know what k is. All right, so now we found k, so let's write our equation. We have t of t is equal to a we found was 130. E to this number, 0.122602322, t plus 35. So there's my equation to solve this. All right, now it said the cake cannot be eaten, or the pastry cannot be eaten until it's cooled to 70 degrees. How long will you have to wait to the nearest minute? So we have to use this equation now to find t. That's what we've got to find. All right, so to find t, we need to know what the temperature is. So that would be T 70, big capital T would be 70. So 70 would go here. E to that number, 226.02322T plus 35. And then go right through and solve it like you would a normal natural log problem. Subtract the 35. And that gives me 35 again, equals 130 e to that number, 122602322t. Sorry about that. All right, solve for e, divide by 130. All right, and that gives me 35 divided by 130. Let me clear this out. 35 divided by 130, and math, enter, 7 over 26. All right, so that gives me 7 over 26 equals e to that number, 122602322t. All right, now we can just do the natural log of both sides. ln of 7 over 26 equals ln of e to that number, 2602322t. All right, this is an exponent, so it goes out front. So this is going to be ln of 7 over 26 is equal to negative 0.01226022322t ln of e. All right, ln of e is equal to 1, so that will cancel out. So to solve this, we just have to divide this by that number, 0.122602322. Oh shoot, I shouldn't have divided that out. All right, so t equals, whatever this is in the calculator. All right, now the reason I said I canceled that out is because I was going to just copy it in the paper. So let me put this back in here for a second. So we got from our original back here to get that k value, it was ln of 23 over 26 divided by 10. So let me put that in. ln of 23 divided by 26, close your parentheses, divided by 10. And I can get that number up there without having to retype the whole thing. Okay, so now in order to enter this in the calculator, the final answer is ln of 7 over 26. Let me do the fraction form. ln of 7 over 26, ln 7 divided by 26, close your parentheses. All right, and divided by, I'm going to go up and grab that. Oops, maybe. Enter. No, it's not going to let me do that. All right, so let me do this a different way. Delete, delete, delete. Okay, let me do it this way. So it's going to be ln of 7 over 26. Oops, to make parentheses. 7 divided by 26. And then divided by this number. So I don't have to retype the whole thing. I'm just going to go up and grab it and press enter. And you get 107.027 is your answer. 027. So it said to round to the nearest minute. So this takes approximately 107 minutes. All right, so that's the process of using the E formula for Newton's law of cooling. It's used for exponential growth and decay. It is a hard way of doing it because you have to remember so many steps, but it does work. So if you've given a problem like this, you can work it out by finding each of the values. Okay, so your assignment is to finish the other problem on this worksheet. It'll be posted on Classroom so you can see it.